nice. Simple, concise. I like it. Okay, Sam.
That one has compressed air in it, so there's more air per the denser amount of air inside that balloon than there's inside that one.
Okay, anyone else who'd like to speak to why this is heavier? Awesome. Let's figure it out. So, does someone want to come up here and like read up? Colin really wants to. Awesome.
Oh, can I read the other one?
Sure.
No.
Okay, so what we are going to do, Sam and Colin, do you guys agree that this is the same balloon?
Yeah.
Do you agree?
No.
Do you want to like mask this and I'll blow it up? And then
No.
Okay. The last class made me do that.
Oh,
Okay,
I'm
so
sorry for you.
it's fine. Okay, so do you guys agree that these are both zeroed out?
Yeah.
Yes. This one has tape on it so that it will hold this, just so it won't roll off. But it is zeroed with the tape on it, so we are not taking the mass of the tape. Are you guys good with that?
Yeah.
Okay, so which do you want to mask first? Okay, we're going to take Sam's. This is the full balloon. What is the mass, Sam?
Wait for it. 2.3.
2.3, what are the units?
Grams.
2.3 grams. Awesome.
Yeah.
Colin.
That's 2.03
No.
grams.
Awesome. So, which has more mass?
Balloon.
Filled with air.
Filled balloon. Yeah. Why does this have more mass? So, I mean, it might be a little bit compressed, but I wouldn't say it's necessarily because of the compressed air. It's because this is a balloon plus air, and this is a balloon. So, it's just what Andrew said. It's really straightforward. It seems kind of difficult because of what Jazzy said. This is more buoyant. It is like more floaty. So, but well, because it has to do with the density of the air relative to the density of the air around it. They're about the same density. So it sort of floats inside of it. So, but it is, we have added air into this. Just because a gas isn't very dense, it does not mean it doesn't have mass. A gas definitely has mass. So balloon plus air has more mass than balloon.
Okay, so why, like when you blow like a balloon, so okay, when you like blow one up with your own mouth, it's like your own mouth. It's like that.
Okay, so yes, it's like this.
Okay, and so when you use helium, it floats. Why is it?
Does anyone have an idea why? Oh, okay. Victoria?
Wait, no.
No. Are you sure? I don't.
Oh wait,
Jessica?
So helium is lighter than carbon dioxide?
Exactly. Helium is a gas that has less mass. It's not as heavy as the gases in our that like came out of my mouth. So it's carbon dioxide and oxygen and other stuff. So helium is less dense. So relative to the air, when you put a helium balloon in the air, it's going to float because it's less dense. But this sort of sinks because it's the same density, so it's not going to float in. Yes.
What temperature does helium condense at?
The next little question for the Thinking Together board.
But
Go do it!
But like, if someone could breathe helium
Someone could breathe helium.
and they breathed on like a piece of paper or something and then it condensed on the piece of paper, the piece of
Excellent
paper
question
float
for the
away.
board.
Would it float?
Well, does density change with state of matter?
Yes.
Your density does change.
But
with
I don't
state
know
of
the
matter.
density of
So
helium
write it up on the
as
board.
like,
Nor do I. Write it. Awesome. So now what you're going to do, you're sort of clustered together. I know these are big, awkward groups. But I didn't move the desks together because I didn't know how many people would be in each group. But what you are going to do in your group, you are going to have a discussion about your question. So you're going to look at your question on the wall, you're going to read it, then everyone in your group is going to share what they wrote. If you did not do the homework, make something up, because I want everyone to contribute to the discussion. So then your group is going to discuss, then you're going to decide how you want to answer the question after everyone has given their input. Then you're going to select one person to speak from your group. and then each group is going to have a chance to speak out to the class. Yesenia.
Do we still do it? Because we pretty much answered it.
So this question, right above Sam's head, is another question for your group. So you guys will address a different question. And then, can I get any volunteers, since our groups are so big and we don't have anyone at the soccer ball, can I get anyone from any group to volunteer to come over to talk about this question? Sam, Brianna, maybe one or two other people? Colin, awesome. Yesenia, you want to come down? Okay, and Yesenia, sweet. Okay, so everyone else, make sure that you sort of cluster together. So you might not all be in a desk and sort of stand around. But so, balloon people talk, tire people talk, and then shaving cream on airplane people talk. So you are all discussing your question, and then you're going to explain your answer to the class in about 3 minutes. So, Stephanie, do you want to come over? So you guys
Question is, how do hot air balloons work? Is our question. So, is there any ideas?
Did you not get these stuff?
Victoria, do you want to go on?
Yeah, everybody but you.
I read the whole thing, but she watched it online.
When you're in your bedroom and it's cold in the house, stand on your bed and put your hands on it.
It's like one of those math problems.
Timmy has 14 pieces of chocolate. What's the square root of 199?
If you read it for a long time, then you need to call and care, it's more vague.
That's not true.
It is. I have 30 seconds.
I would try this, but I
So,
can't.
during the winter, it is
No, I did that one.
Which group are you in?
like,
Okay, awesome. So make sure that
I
everybody
thought about it, I was like,
So this group, I know you're a large group, but make sure that everyone is talking and contributing. Mark, stop messing with me stuff. Mark. Leave her be. Okay, so everyone's talking. And then Jessica and Victoria, I know they're far apart, but they're all a part of your group.
well, like the actually,
So who is
are
discussing?
she talking about like what it means to the wall or what it means to the game? How does it handle air temperature?
The amount of air So,
I can't see that.
Wait, so the question is talking about how does the air and temperature affect the wall? Oh,
so we already found it.
okay.
Well, good.
Because,
guys gotta get
first of all, air densities at
Maybe like
different temperatures. And second of all, if you're in an area of high pressure, then the
Yeah, I mean, if you think about water becoming gas, the only way to do that is to and so the hotter that air gets,
1.1 if you're in an area
I like it. Dakota.
So the less air below that.
Conclusion?
my diction friggin'
Oh, fine. Thank you. So kind, Sam.
Miss Bronner, I spotted some little birds.
Ow! It's their day of recovery.
These guys are my people.
Okay, cool.
I am sleepy, I'll tell you that.
Okay, awesome. And then, have you guys developed a conclusion?
Are you currently? Are you currently?
I know it's after 30.
I'll do it, yeah.
All right. So give me a thumbs up if your group has come up with some sort of conclusion. If your group has something to say, give me a thumbs up. Group up there, have you guys figured it out, or do you need another minute? What? Do you guys need another minute, or are you good? Okay, just checking. I'm just checking in, make sure every group. So now raise your hand if you're the speaker for your group. Okay, Sammy, Colin, Ambrose, and okay, awesome. So I have visuals to go along with each of these. You do not need to use this. I will just elaborate with the visual, so I think it will be helpful for everyone if we have your explanation and then the explanation with the visual. So we're going to have the shaving cream people go first. So Dakota, you are up, sir. Very nice.
Yeah, boy, volunteer.
And then also, everyone who speaks, if you could start off by reading the question so that everyone's on the same page. So if Dakota, you could start us off.
Why do you? Why do compressed containers like shaving cream or hairspray burst open and put on a plane? Why do shampoo bottles pop open? Well, containers like shaving cream, hairspray are already compressed. And the higher you go, the less dense and less compressed it is. So it's going to pop open because of how compressed it is on the inside.
Very nice. Awesome. Thank you very much for that. That's awesome. So okay. Okay, Andrew, thank you for congratulating. Okay, so I want to elaborate and clarify one point. That was an excellent job, Dakota. So this diagram shows, like, if I had a bottle of shaving cream right here. This bottle of shaving cream exerts a pressure. So as Dakota said, it is pressurized, meaning there is pressure pushing on the outside of the container. Guys, we're focusing up here. And there's also atmospheric pressure. Pressure from the atmosphere, which will clarify what that is and how we understand it in a little bit. There's atmospheric pressure pushing down. Right now, if I had a bottle of shaving cream here, the pressure pushing out has to be equal to the pressure of the atmosphere pushing in. So these are the same. Then, when you increase your altitude, as Dakota said, the air gets less dense. The air thins out. The atmospheric pressure decreases as you go up. So these arrows are smaller. Atmospheric pressure decreases. And now, even though the pressure inside has stayed the same, the pressure inside is now greater than the pressure outside. So what's going to happen if there's more pressure pushing out than pushing on in? It explodes. Thank you very much, Dakota. Sam?
That's like when you go to, like, for example, we went to Colorado and we wanted to play tennis, and we had to get, like, we brought tennis balls, but they, like, didn't bounce because it was such a higher altitude.
That's
so,
an excellent
the ball
example.
would, like, we'd hit the ball and it would just die, like, immediately.
That's an excellent example. That's awesome. Yeah, the altitude, the change in air pressure can really have a dramatic effect on a lot of these things. Colin.
Mine. Oh wait. Oh, I'm actually.
Oh no, you can go. Whatever you're gonna say.
Oh, as far as that
Guys, I just want to say we're being really respectful of when other people talk. So your group will have a chance to speak, and if you are the person speaking, then you will have a chance to speak in front of the class. But everyone has had their time to share in their group, and we're being respectful of everyone else who's speaking.
I know that this summer when I was like leading mountain tour guides and stuff, I would tell my backpackers not to carry compressed sunscreen or like aerosol sunscreen because A, we're going to high altitudes, and B, it was really, really hot, like 106 degrees. So of course you have higher pressure in the can and then lower pressure in the air around it. So people, like, you would hear someone like walking and all of a sudden you'd hear a pop. And they'd like open their bag and everything would be covered in sunscreen. It was horrible.
Wow.
I was like, I told you not to bring
awesome. It's a really, an awesome example. Terrible that happened. Okay, Colin. Hey, Colin, read your question, please.
Okay. In international soccer competitions, the soccer ball's mass must be between 410 and 450 grams, and air pressure must be between 0.6 and 1.1 atmospheres. So how does the amount of air or air temperature affect these values? Okay, so air temperature will affect the values of the pressure inside the ball, such as if it's a colder temperature, the air pressure will go down, like towards the 0.6 range, and if the temperature is hot, it'll rise up to the 1.1 range. The more air that you have in the ball, of course, the higher the pressure because there's more mass inside a limited space, and the lower the amount of air, the less pressure in the ball.
Excellent. Thank you very much, Colin. All right, so as my little diagram shows just what Colin said. So you have a soccer ball, and I just showed the example, so if you heat it, if there's you adding hot air or somehow heat the soccer ball, then what's going to happen? What assumption did we talk about on Friday that talks about when we increase temperature, what else is going to increase? Sam?
Is it the movement?
Exactly! The velocity. So your speed is going to increase. If you increase speed, what form of energy is going to increase? Kinetic energy. Awesome. That is our fifth the average kinetic energy of gas particles depends on the temperature of the gas. So as you increase your temperature, you're going to increase speed, which increases average kinetic energy. And in soccer, why they set these regulations is because if you increase that speed, then just as Colin said, you're going to increase the pressure of the gas pushing on the ball. So the ball is going to be firmer. So when you kick a soccer ball that's more firm, it goes farther. So it's easier to kick a ball that's firmer. And anyone who is in soccer can clarify or correct me on that. But, so is that, am I right, Yesenia? Awesome. So they have to set those kinds of regulations because it is a form of cheating to affect the ball in that way. So, very nice. Now, tire people. I think Ambrose. Very nice. Come on down.
Why do people tend to have to fill up their tires with air more during the winter than during the summer? Well, so we talked about how the air in the summer is usually a lot warmer, so that means that the atoms are moving a lot faster, and so the tire, and you have a lot of atoms moving, it's going to expand. So you want to put less air so that they don't bust while you're driving. In the winter, the atoms are moving slower, so you want to put more air so that they don't kind of flat on it. So that's essentially what we talked about initially.
Yeah, that's excellent. So this question and the soccer ball question are very similar. So if you add heat, again, back to assumption number 5, increasing temperature increases your average kinetic energy. The particles are going to be running around faster, so that increases the pressure. Just like Ambrose said, that's why tire blowouts are more common in the summer, because you have an increased temperature increasing the pressure in your tire. And then in the winter, that speed, the average kinetic energy is lower because you are at a lower temperature. So that's why you usually need to fill up your tires with air, because you have the same amount of air, but the particles are moving slower, so they're exerting less pressure on your tire. Sam?
I know, like, if you go to other countries like Germany, there are like areas that don't have speed limits, and you have to have tires that are like rated for faster speeds. Is that because when you drive faster, they heat up more and they're more likely to blow? So I know, like, if you have tires that are rated for like 75 miles an hour and you're driving like 100, then they can blow and you can die.
Yeah, it's probably a combination of this issue and also just like the rubber itself melting.
Okay.
It's probably, but yes, it's probably a combination of this and like the quality of the rubber. But I'm not 100% sure. You're welcome to put that on that board to get a better answer. Yes. Okay, what else? Okay, now hot air balloons.
I don't know. You said both of us. Do you want us to?
Sure.
I mean,
That's awesome. Come on down.
Cool.
Very nice. If you could read your question. Oh, it's not on.
It's not there. How do hot air balloons work?
Fantastic. So they had a different question than was on there, just because we answered their question at the beginning of the class. Take it away.
So basically, hot air rises, and that's
that's really it.
Why does hot air rise?
Ooh, she got you.
It's more compressed, no, or less.
So think about if you are increasing the temperature, what else are you increasing? The speed, the velocity, so increasing the average kinetic energy. If they're moving faster, are they going to be more or less dense?
Less dense.
Less dense. Because the faster you move, the more space you can cover, so the more you can expand. So hot air rises because
Air is less dense.
because hot air is less dense.
So in these balloons, they're like literally just, what do they use to generate that heat? I don't know. I mean, isn't that like,
Yeah, they have some sort of.
that's kind of terrifying when you think about it. Like, what if it catches fire? It's just like
There's some sort of
miles
fire
out.
system here, and then I'm sure that these balloons are flame retardant or something. But I don't know very much about the specifics about the balloons, but the way they work is on that principle. That hot air does rise, and it rises because it's less dense, because of the assumption number 5 that we talked about, that increasing temperature increases average kinetic energy. Very nice. Anything else you would like to add, ladies? Very nice. All right. Okay. What questions? Does anyone else have any clarifying questions about any of these that we talked about? Okay. You all did a super awesome job of thinking through these, and thank you very much for setting aside some time this weekend to think about them. Sarah?
So, when you guys were like talking about the shaving cream, okay, is there like a specific pressure that they're supposed to put it at?
You mean airplanes, or like when you create a shaving cream?
When you create one.
I'm sure there is, but I don't know. I'm sure there is a specific pressure that you have to put it at so that it doesn't burst open. But that's an excellent question that you can put up there. I don't have a specific answer, but I'm sure you're right. Go! Yeah. Sam. Okay, while Sam is doing that, everyone else, you're getting out your guided notes packet from Friday.
I don't understand why would it explode, because they keep cabin pressure inside an airplane like to the same pressure that it is.
It's actually, Jonathan last period, he informed me that cabin pressure is set to like to 5,000 feet above sea level or something like that. So it's actually set to be lower than atmospheric pressure at sea level. But yeah, so it is, and even it is slightly different from the atmospheric pressure that we're all normally used to. And that's also by the top of your ears, because you're experiencing those pressures. You do not have to turn those in.
Okay, also I don't have the notes.
Yeah. All right, was anyone else gone on Friday and needs a copy of the guided notes?
That's better.
Sorry. You can